How do you determine which piece of software requires how much testing? For that, we need to know the cyclomatic complexity. The name itself shows it is complexity. This technique of finding cyclomatic complexity, it is called McCabe's cyclomatic complexity. It gives you three questions, answer for three questions. Is the program or software testable? Is the software understood by everyone? Is the software reliable? So the cyclomatic complexity gives the upper bound. I'll just tell you that this is a mathematical, you can say, way of computing the number of test cases you can. This is the highest number of test cases you can do, and then you know the test cases, and then you can go beyond that if you want, but this is the upper bound. So entire life cycle, if you know the code, or even if you know the flow chart, even if you know the PDL, the procedural defined language, or the algorithm. So cyclomatic complexity gives you the upper bound of the number of test cases you have to write. Okay, this is the one line answer. It gives you the complexity also, how much test cases you have to make, whether your software is complex or not. So let us take an example. Here is your you can say a basis path you have made, and now you have certain if else, certain do whiles, certain conditional and logical, all these things are happening. Don't go into the detail of that. I'll just give you the how to. There are ways to find out, three ways, and most of the time they'll come. I'm just saying that if you have number of instructions that are not doing any conditional or logical work, you can just combine them. So one node can be, say, having 100 instructions. So these are the edges and these are the nodes. And most of the time the nodes which we are interested in is about number of branching. So E minus n plus 2, edges minus node plus 2. In this example, we have the edges number is 12, n is nodes are 8, 12 minus 8 plus 2 is 6. Second thing is predicate node. Predicate nodes are all those nodes which have more than two or more than 2 branches coming out of it, or nodes, these edges coming from it. So just count the predicate nodes and add 1 to it. And there is one more way. Count the number of regions. Region are the closed circuit which we are making. 1, this is 2, all these are closed, 3 and 4 and 5, and then we add one more which is the outside, that is also one region. So how many regions are there? 6. So every time we are getting the cyclomatic complexity as 6. Okay, this is all about this discussion. Thank you so much.